Okay, so in this video, we'll be going over soil loads. So our objectives here are to be able to understand and apply soil loads, and we need to be able to find vertical and horizontal pressures to do so. So for some quick review, force is equal to pressure times area, and our vertical soil loads, sort of roughly shown here as such, you can find the pressure using density times depth. Now our horizontal loads, we're introducing a new component here. Again, similar to hydrostatic loads, it acts in a triangular form. So we're adding the property of material, which is referred to as K for the horizontal loadings. And this could be, for example, something like 0.4 for soil. And it just depends on what material you're actually looking at. So now that we've reviewed the concepts, we can take a look at this question. So we're given different components here, the weight density and K, and we need to find the vertical loading just on the bottom face, and the horizontal loadings acting on each of the four sides. So not the four sides total, but just on one of the sides. So take a moment and try these on your own, then come back to the video. Okay, so here we have our square cube, and we're looking at the vertical load of the bottom face here. So let's just call this Fy. So here's our bottom face. We'll label this area AB, and of course it's all 1 meters. Fy is equal to the pressure of the bottom times the area on the bottom. And the pressure on the bottom is equal to density times depth multiplied by our area bottom here. So if we input these values, density, of course, we were given. Our depth is also 1 meter, as shown here, and we're multiplying by the full area, which is 1 meter times 1 meter. So all the meters cancel out, so you just get that Fy is equal to 15 kilonewtons, making this the correct answer. Now moving on to the horizontal loading here, which we'll label Fx. Here we have the sides shown here, and there are 4 of them, and each are 1 meter by 1 meter. However, the actual loading itself is triangular. So the pressure comes in this way, and this is actually the area we'll be looking at. So force X is equal to PS times AS, and if we input some values, you get 1/2 times K, because we're dealing with a horizontal loading here, times the density times the depth, times 1 meter times 1 meter. So this 1/2 comes from the area because we're doing a triangular loading. I just put it at the front to be able to remember to do it. So you'll then get the 1/2 times 0.4 times 15 times 1 meter times 1 meter squared will be our horizontal loading. So you get that Fx is equal to 3 kilonewtons, which is per each side. So that makes this the correct answer. So in summary, here are the loadings and their answers. Thank you for watching this video.